All right, welcome back. Today we are going to talk about switch statements and finite state machines in processing. And so, what are those? What the heck is a finite state machine? Well, before I tell you what it is, I want to tell you what this is used for and why it's going to be useful for us. So, why are we going to use this thing called a finite state machine? Well, because this is going to help us make a changing system in our program. And so, what kind of system? Well, that's what's kind of neat about it. It can be any system. It's going to allow us to make something that can change over time. For example, let's say you're making a game in processing. Maybe you have certain levels where every level has a different amount of enemies, and maybe the player moves at different speeds, something like that. Well, how do you change between those different levels and have those different settings be applied to each different level? Well, a finite state machine can help us do that. So it can help us change between different levels in the game. It can do something similar, like it can help us change between scenes and animation. If you're drawing like an animation thing and processing, something like that. Maybe if you're doing a game or just some other kind of interactive art piece, maybe you have different control systems, right? And maybe at one point in time you want to control a moving player using control system A, but then in 20 seconds you want to change the controls to system B, something like that, right? Where you want to change kind of on the fly your system that you're working with. Well, a finite state machine will help you do that. So let's talk about what a finite state machine actually is, right? And so it's a bit of a fancy name, finite state machine, but it's actually a very simple concept. If we break that down, finite state machine, well, finite means, well, it's not infinite, so there's, a certain number of things in here. State, okay, so what's a state? Well, a state is just a certain kind of setup for the way things are. So if I go back to like maybe the levels example, where maybe you have different parameters for every level, where maybe the player speed goes up as you go up to a different level, maybe the number of enemies increases as you go up to the next level. And so those would be part of the state. So, the player speed, the number of enemies, that's going to be qualities of a certain state, right? And so a finite state machine is just going to be a collection of states. So a collection of kind of setups that we can then change between. So for example, maybe if you're making a game, you have a start screen, which just says, hey, welcome to my game, press this button to start. Then it has the game itself, and then maybe it has a winner screen or like a losing screen or game over screen or something. We can think of these different things, the start screen, game, and winning screen, as different states, right? What a finite state machine helps us to do is just change between those different states at the appropriate time. And maybe as well, if you have different levels, maybe you have a start screen, you have level 1, but then level 2, and then level 3, however many you want, and then an ending screen. Well, those are each different states. And a finite state machine is going to help us change between those different states. And so let's jump straight into how do we make something like this in processing? Well, you need a few things. First off, you need to make a variable. You can call it whatever you want. I call it switch val. It's either going to be a character or a number, and I will show you different examples of that here in a second. But it's going to have a value, which is either a character, which is just like the letter A or something like that, or a number. And then once you have that variable, what you're going to do is make you're going to use switch cases. That's what it's called, switch cases. How do you do that? Well, that's what this block of code is right here in my draw. So you see how I have the word switch in screen? So processing recognizes it. It's built into processing. What we're going to do is with this switch case system, we're going to tell processing how we can switch between different cases. So switch cases, we're going to tell it how we're going to switch between the different cases. In this situation, these cases are going to be different states. And so you can see I actually have an example here. So let me break it down for you in that example. So what I have here in my little processing window is the same as I was showing you here in this picture in the slides. And so I have a variable. I always call it switch val because it's going to be a value I use with my switch cases. You can call it whatever you want, but I think switch val is a perfectly reasonable name. It makes sense to me. You then need to have a type for your variable, of course. It can be either int or character. Let's start off by making it an int. So I just made it 0. Cool, whatever. So let's look now at this switch case system here. How do I make it? Where I said the word switch, have my parentheses, and then I have my variable put in these parentheses. Remember, I called it switch val. But then we see, if we look at this in detail, we have case 0, case 1, case 2. So these are different cases in our situation. But a case is just different state. So we basically have state 0, state 1, and state 2. And so let's look at these different states. What does each state say with this particular setup? Well, it says that, okay, state 0, it says, hey, make the background red. Then I have this break word here. Okay, we'll talk about that in a second. If we look at state 1 or case 1, what does it do? Well, it just makes the background green. Okay, then we have a case 2. What does it do? Well, it makes the background blue. Now, and then each of these also have this break statement. All this is me saying, hey, I want to make a finite state machine. Once I say the switch word, it means, hey, let's make a finite state machine. I pass in my variable. This variable is going to have some different values. Whatever value that it has, that's the state I'm going to go to. So right now, my switch val has a value of 0. So what's going to happen is that whenever I run this code, it's going to say, okay, switch val is 0, so let's go to case 0. In that case, it's going to make it red. So in fact, I'm even going to press play here. You'll see what I mean. You see it made the background red. That's because switch val is 0. So when I went to my finite state machine here, it said, okay, what state should I be in? Well, I tell it, well, look at this variable. Since this variable is 0, it went to case 0. Just to play with this, if I come here and change my switch val to 1 and press play, you see now it says, okay, here's my finite state machine. What state should I go to? Well, you should look at switch val. Well, switch val is 1, so it goes to case 1. And it makes the background green. And of course, if I say switch val should be equal to 2, press play, it's going to be blue because that's what case 2 says to be. Now, if I say a different state, like go to state 3, but you see I don't have a case 3. If I press play, you see it doesn't do anything. It just leaves it at the default. And so I don't define a case 3, so it just ignores it all, and it leaves it blank. And so hopefully you're seeing kind of this logic here, where if I have, you know, my variable switch val, it says what state it should be in, right? And then it just goes to that state. So you can imagine if you're making a game where you want to change between the start screen and then the main part where you play and then like a game over screen, you could have, like in your first case, all your code that displays everything for your start screen. Then in your next case, you could have all the code that's involved with running the actual game. So if we think back to like a Pong example, which I can even show you here in a second, this bit could be like, you know, it shows a thing, it says, welcome to Pong, press, you know, the S key to start. That's all this bit of code would do. This bit of code, maybe that's running the actual game of Pong. So what will this bit of code say? Well, this bit of code will say, okay, this is how you move the players. You know, if you press the keys, move the players up and down, just move the ball back and forth, record the scores, display all that. You know, it just has all the code that kind of regulates the game of Pong. This, let's say this is going to be the case for our game over screen, let's say, or the winning screen, right? Because if someone wins, then this bit of code would say, hey, player 1 wins because they got the max score, player 2 wins, or whatever. And so by having these different states here in these different cases, it helps us make a system that can change between these different states. Now, so far, I've just changed the value switch val manually, and that changed what state I'm in. But let's say I'm running my program and I want to change it because a certain condition happened. Like maybe the players scored 10 points, then I want to go to the winning screen, something like that, right? How do I make it change, you know, which state I'm in while the program is running? Well, it's very simple. All I have to do is change the value of switch val. And so the way I'm doing that here in this example, if I go down to my key press function, what I'm doing is whenever I press a key, I increase switch val by 1. But if switch val ends up more than 2, then I just change switch val to be equal to 0. And so, it just restarts the switch val over. And so let's play with that. If I press play, okay, it's red. It's because switch val starts off as red. But if I press a key, you see it changes to green. That's because what have I done here? I've added 1 to my switch val, which means I am no longer in case 0, I'm in case 1, which makes it green. I press a key again, it goes to blue. Same logic here. And again, if I press it one more time, it goes back to red, because that's what this if statement says. If switch val is greater than 2, then make it equal to 0. So just to prove to you that that's what's happening, if I come here and say print line switch val, and I run my code again, see it's red, and my switch val is 0. If I press a key, switch val changes to 1, my case changes to green, press the key again, switch val changes to 2, well, my background goes to blue because I'm in case 2. So hopefully that's kind of making sense to you. If we look at this, I want to emphasize some of the structure here. If you want to make your finite state machine, you say the word switch. You have your parentheses, and then in between your parentheses is whatever variable you're using. I call mine switch val. Then you have your brackets, just like any other block of code. Then you have the word case. And then after case, it should be a value that switch val can have. And so for me, switch val could either be 0, it could be 1, or it could be 2. So that's why I have those 3 cases. I then have a colon, and then after that, I have all the code I want that should kind of belong to case 0. But notice, I also have this break statement here. What this break statement does is it tells processing that whenever it reaches this point in the code, then that's the end of this case. So leave the finite state machine and continue on down. So what that means is that you need to have this break statement in every case that you have in your finite state machine. You can't, if I have a case 0 here, I can't have it where there's no break statement. It's not going to work properly. It's going to maybe run more than one case at a time, which is not what you want. And so you have to make sure you always have a break whenever you have a case. And it's very easy. You just say break semicolon at the end of the case. And that's basically it. And so you can see you actually can have a system here where it's very easy to change between different states. And so I can even show you an example with Pong. I want to show you code because that's an assignment for you. But if I press play here, you'll see that I'm on a screen and it says press R to start. This is like my start menu. This is actually my first case. So if I press the R key, you see now it changes to where I can play the game Pong. I can move around and play. And then player 1 got enough points to get to the winning screen, so then I move to a different state, which is my winning screen here. So you can see it actually allows me to change easily between different parts of my game. And if I press the R key again, you see I just restart and I'm back into my game, so I can play some Pong, and then I'll have player 1 win again. Let's have player 2 win. And boom. You see then it moves to another screen, another state, where it says player 2 wins. There's no more game going on. I don't have to worry about the players being overlapped with this text here. It's a completely different state. And so that's pretty cool. And that's basically it. I challenge you to, if you have Pong, if you're in the 103 class, you made Pong many weeks ago, probably. It's one of the weekly assignments. I encourage you now for your assignment to pull up Pong and actually add some of these switch statements in here, or add a switch statement with 3 different cases. Or actually, I think it'd be 4 cases. The first case would be the start screen. So that'd be like when I pressed play here. I get this screen right here. It tells you how to start. And, you can have a little welcome thing, like says something like "Welcome to Pong," or just have the title Pong or something like that. Have another state in your finite state machine, which is the game itself. So it should play. And then I think you'll have 2 more cases. One that which says player 1 wins. Another case that says player 2 wins. Then all you have to do is you have to make sure that you change between those different states appropriately. So if you have, your finite state machine and you're using a switch val, make sure that you change switch val to an appropriate value whenever you Well, whenever you want to, right? So for me, when I press the R key, I change my switch value from 0 to 1. And then whenever the player 1 reached the max score, it changed to a switch value of 3, which is the player 1 win screen. Or if the player 2 got enough points, switch value was changed to 4, which was the player 2 win screen. And so, yeah, I give you that as a challenge. And I think that's all I really want to cover here. It's actually a pretty straightforward, simple concept, but it's also pretty powerful, and it can really help us organize our code and help us do different things. So I hope this was helpful to you, and thank you so much for your time.